In this video, we're going to go over question number 4 from the Chapter 2 review. So here we say that the current policy is, or the current default is that we have a random string of 6 alphanumeric characters selecting from the following list without repetition. So we're going to select any letter, any number, and any of these character, and we have to select 6 of them. So the question is, well, how many different ways can we do that? How many different passwords are possible with this configuration? And so I just need to think about, okay, well, I'm choosing 6 things. How many ways can I choose the first thing? Well, in total, I've got 26 letters, 10 numbers, and then if I count it out, there's 8 of these that we've said are acceptable. So that's 26, 36, 44 possible choices here. So whatever I choose for the first character, there are 44 ways to do that. And now because we're saying without repetition, that means I can't choose the same thing again. So whatever I chose for that first one, I had 44 choices, but now I only have 43. And then now I've chosen 2, so only 42, and then 41, and then 40, and then 39. And now I've made all 6. 1, 2, 3, 4, 5, 6 choices here. And so if I just multiply that out, I get a fairly large number. 5, this is all part A. 5, 0, 8, 2, 5, 1, 7, 4, 4, 0. So that's a lot of choices. Part B says, well, how many could we do if we did allow repetition? Well, it's going to be the same idea. It's just that these aren't going to decrease. They're all going to be 44. I have 44 choices for every single slot there. So that's really just going to be 44 to the 6th, which if I plug that into my calculator, I should get 7, 2, 5, 6, 3, 1, 3, 8, 5, 6. Okay. Now part C, go over here, might need a little more room for this one. Now it says, okay, I have to choose 2 letters, 2 numbers, and 2 special characters, again without repetition. So this is going to be, okay, 2 letters, so that's 26 options. Now back to without repetition, so 25. Then 2 numbers, so 10 for the first number, 9 for the second number. Then for my special characters, 8 and 7 because it's without repetition. That is 3, 2, 7, 6, 0, 0, 0. But this is a really sneaky one because the way that I've written this, this implies that I'm choosing letter, letter, number, number, character, character. And that doesn't have to be true, right? It just says I have to have 2 of each type. But it doesn't say that it has to be 2 numbers, 2 letters, then 2 numbers, then 2 characters. I could do characters first and then numbers. I could mix and match. So the question is, okay, how do I have to modify this to account for that? And we need to compare this with like the Chipotle example that we did at the beginning or in class when we were talking about these where I had 2 options for rice and 2 options for beans and like 4 options for meat. And in that context, it doesn't matter which choice I make first, you still end up with the same burrito. Similarly with Mr. Moen choosing his outfit where he's got to choose his shirt, pants, shoes. It doesn't matter which one he chooses first. He still ends up just choosing shirt, pants, shoes. But here, it actually makes a big difference. So I have to actually, instead of dividing out as we did in the previous problem, where we say, oh, it doesn't matter what order I list these things in. Now, it really matters. And so I have to actually think about, well, how many more ways could I re-scramble this up? And if I think about it, I've got 6 slots here. So how many more ways could I rearrange those 6 slots? Well, 6 factorial. So I actually have to, which is of course 6 times 5 times 4 times 3 times 2 times 1, because now I'm thinking, all right, what am I going to do first? Is it going to be number or letter or special character? And I can rearrange that a whole bunch of different ways. So now I need to actually multiply this thing by 6 factorial to say that I've rearranged this all those different ways. And that number is 2,358,720,000. And that is my answer. Pretty sneaky here with this extra 6 factorial there.